Today, we are not just looking at volcanoes, we are peeling back the skin of the earth to understand the fire that burns beneath. We will journey to the heart of eruptions that have buried entire civilizations, witness glowing avalanches of ash that move faster than a race car, and confront the reality of a threat so vast, so existentially profound, it doesn't just endanger cities or countries, but our entire species. This is the story of the Earth's inner fury. These are 100 terrifying facts about volcanoes and supervolcanoes. Our story, as it must, begins with a city that became a tomb. We travel back in time to the year 79 AD, to the shores of the Bay of Naples, in the shadow of a mountain that the people of the Roman Empire considered a gentle, green giant. Mount Vesuvius. For the 20,000 residents of the bustling, vibrant, and wealthy city of Pompeii, it was just a beautiful backdrop to their daily lives, its slopes covered in lush vineyards. The tremors that occasionally shook the ground were just a normal part of life in the region. They had no idea they were living on a geological time bomb. They didn't even have a word for volcano. It was just a mountain. Then, one fateful August afternoon, the mountain exploded. The initial blast was colossal, a sonic boom that would have shattered windows for miles around. A Roman admiral and naturalist, Pliny the Elder, witnessed the event from his fleet across the bay and described a cloud of unusual size and shape, rising like a colossal, dark pine tree into the sky. This was the birth of modern volcanology, a description of what we now call a Plinian eruption, the most violent and energetic type of volcanic event. It was a vertical column of superheated gas, ash, and pulverized rock, punching over 30 kilometers, 3 times the cruising altitude of a passenger jet, into the stratosphere. For the next 18 hours, Pompeii was subjected to a terrifying ordeal. The sky turned to blackness at midday, lit only by flashes of volcanic lightning within the towering ash cloud. A relentless rain of light, porous rock called pumice and hot ash began to fall on the city. It accumulated at a rate of 15 centimeters an hour, collapsing roofs, trapping residents in their homes, and slowly burying the city. Some people fled, but many stayed, believing they could wait out the storm. This was a fatal mistake. The worst was yet to come. As the upward momentum of the eruption column began to fail, it collapsed under its own immense weight. This sent a glowing, superheated avalanche of ash, pumice, and toxic gas racing down the mountainside directly towards the nearby city of Herculaneum and then Pompeii itself. This is a pyroclastic flow. It is not lava. It is a fluidized, turbulent cloud of incandescent particles, moving at hundreds of kilometers per hour with a temperature of over 700 degrees Celsius. It is an unstoppable, unsurvivable incinerator. It moves with the power of a hurricane and the heat of a blast furnace. The first wave hit Herculaneum, instantly killing everyone. When it reached Pompeii, it was a wave of death that killed not by burning, but by extreme thermal shock. The intense heat would have boiled people's brains and vaporized their soft tissues in a fraction of a second. When archaeologists began excavating Pompeii centuries later, they discovered something extraordinary. The layers of hardened ash had perfectly preserved the city. But they also found strange, empty voids in the ash, in the shape of human bodies. The great archaeologist Giuseppe Fiorelli realized that these were the cavities left behind by the decomposed bodies of the victims. By carefully pouring plaster into these voids, they were able to create perfect, hauntingly detailed casts of the people of Pompeii at the exact moment of their death. A dog, chained up, writhing in its final agony. A family, huddled together under a staircase in a final, futile embrace. A man shielding his face from the coming heat. These plaster casts are a permanent, chilling echo of the human cost of volcanic fury. Pompeii wasn't just a natural disaster, it was a mass mummification event, a city flash frozen in time by the superheated breath of a mountain. So why did this happen? Why here, in this seemingly idyllic corner of the world? The secret, the engine of this destruction, lies in the very structure of our planet. The Earth's crust is not one solid, continuous piece. It's broken into about a dozen major tectonic plates and many smaller ones, like a cracked eggshell or a giant, slow-moving jigsaw puzzle. These plates are in constant motion, sliding past each other, colliding and pulling apart, driven by the immense convection currents in the molten mantle beneath them. And where these plates interact, you get geological action. Earthquakes, mountain building, and volcanoes. Mount Vesuvius sits in a particularly nasty spot, where the African tectonic plate is slowly diving beneath the Eurasian plate, a process called subduction. As the African plate sinks deep into the mantle, it carries water-rich ocean sediment and minerals down with it. The immense heat and pressure of the mantle effectively cook this water out of the descending rock. This water then rises into the wedge of mantle rock above it. Now, you might think adding water to hot rock would cool it down, but under these pressures, it does the exact opposite. It dramatically lowers the rock's melting point. This creates vast quantities of buoyant, sticky, gas-rich magma, which desperately wants to rise to the surface. Vesuvius is the result. It is a geological pressure cooker, slowly building up a charge of explosive magma over centuries until it can no longer be contained. This process of subduction is responsible for the most famous and most dangerous volcanic chain on Earth, the Ring of Fire. It's a 40,000-kilometer long, horseshoe-shaped path that traces the edges of the massive Pacific Plate from the tip of South America up through North America, across the Aleutian Islands, down through Japan, the Philippines, and into New Zealand. It is home to over 450 volcanoes, which is more than 75% of the world's active volcanoes, and it's where about 90% of the world's earthquakes occur. This is the planet's grand central station for geological violence. Mount Fuji in Japan, Mount St. Helens in the United States, Krakatoa in Indonesia, they are all siblings in the same fiery family, born from the same process of subduction. But not all volcanoes are born from the destructive collision of plates. Some are born in the peaceful middle of them. The Hawaiian Islands are the most famous example. They are the product of a hotspot, a place where a colossal, stationary plume of superhot rock from deep within the mantle, perhaps from the very edge of the Earth's core, punches its way through the crust, like a blowtorch melting through a sheet of steel. The Pacific Plate has been slowly sliding over this stationary hotspot for at least 70 million years. As the plate moves, the hotspot punches a new hole, creating a new volcanic island. This is why the Hawaiian Islands form a neat, linear chain from the old, eroded, and now dormant islands in the northwest to the young, active Big Island in the southeast, where Kilauea and Mauna Loa are still being built today. There's even a new Hawaiian island, a seamount named Lihi, currently forming in the deep ocean to the southeast, which will break the surface in about 10,000 to 100,000 years. So, book your vacation rentals now. Don't want to miss the rush. The profound difference in how these volcanoes are born also dictates how they erupt. The magma at subduction zones, like Vesuvius, is what's called felsic magma. It's rich in silica, which makes it incredibly thick and viscous, like sticky peanut butter. It also traps vast quantities of dissolved gases, like water vapor and carbon dioxide. This is a recipe for an explosive, catastrophic eruption. Think of shaking a can of soda and then trying to open it. The pressure builds and builds until it is released in a single, violent blast. The Hawaiian hotspot magma, on the other hand, is mafic magma. It's much runnier, like honey, and has less trapped gas. So when it erupts, the gas can escape easily and peacefully. The eruptions are effusive, not explosive, creating spectacular, mesmerizing rivers of lava, but not the terrifying, stratosphere-punching columns of Plinian eruptions. This is why you can get relatively close to a Hawaiian eruption and watch the lava flows, but a Vesuvius-style eruption will kill you from miles away before you even know what's happening. And this brings us to the many, varied, and often insidious ways a volcano can kill you. The lava, while iconic and visually terrifying, is actually one of the least deadly volcanic hazards. It generally moves slowly enough for people to evacuate. The real killers are far faster and more unpredictable. We've already met the pyroclastic flow, the glowing avalanche of death. In 1902, on the Caribbean island of Martinique, Mount Pelee unleashed a pyroclastic flow that completely annihilated the city of Saint-Pierre in less than 2 minutes. It killed all but 2 of its 30,000 residents. One of the survivors was a man named Louis Auguste Cyprus, a prisoner in a poorly ventilated, partially underground, dungeon-like cell. The thick stone walls shielded him from the worst of the heat, though he was still severely burned. He was later pardoned and joined Barnum and Bailey's circus, touring the world as the man who lived through doomsday. But what if the volcano is covered in snow and ice? Then you get another deadly threat, the lahar. A lahar is a volcanic mudflow, a terrifying slurry with the consistency of wet concrete. The intense heat of an eruption can instantly melt massive glaciers and snowcaps on a volcano's summit. This unleashes a torrent of water that mixes with the loose volcanic ash, rock, and debris on the slopes. The result is a fast-moving, destructive river of mud that can travel for tens of kilometers, burying everything in its path under a thick, heavy layer of material that quickly sets like cement. In 1985, a relatively small eruption of the Nevado del Ruiz volcano in Colombia melted its summit glacier. It triggered a series of lahars that raced down river valleys and completely buried the town of Armero. Over 23,000 people were killed, most of them while they were sleeping. The town wasn't hit by lava or ash. It was drowned in a river of hot, liquid cement. But you don't even need an eruption to be in danger. Volcanoes are constantly breathing, releasing a cocktail of gases from their vents and fumaroles. Most of the time, these gases, like sulfur dioxide, create a volcanic smog, or VOG, which can be a respiratory irritant. But sometimes, they are silent, invisible killers. In 1986, at Lake Nyos in Cameroon, a deep crater lake formed in a dormant volcano. A catastrophe occurred. Over time, a huge cloud of carbon dioxide had been seeping from the magma below and dissolving under pressure in the deep, cold lake water. Something, perhaps a landslide or a small eruption on the lake floor, disturbed this stratification. The CO2-rich water rushed to the surface, and the dissolved gas came out of solution, like opening a giant soda bottle. A massive, invisible cloud of over a cubic kilometer of CO2 gas was released. Because CO2 is heavier than air, this odorless cloud rolled down the valleys, displacing the oxygen and silently suffocating over 1,700 people and thousands of livestock in the surrounding villages. It was a silent, invisible flood of death from a sleeping volcano. So you can be incinerated, buried alive in concrete, or silently suffocated. Fun, right? But wait, there's more. What if the volcano could also shoot lightning at you? During a powerful Plinian eruption, the friction between the billions upon billions of tiny ash particles, rock fragments, and ice crystals in the eruption column generates an immense amount of static electricity. This results in spectacular and terrifying displays of volcanic lightning. It is a full-scale electrical storm happening inside the ash cloud itself, a dirty thunderstorm of epic proportions. Its nature at its most apocalyptic, a scene straight out of a heavy metal album cover. And the rocks a volcano throws can be just as strange and varied. Pelé's hair, refers to thin, golden strands of volcanic glass, formed when droplets of molten lava are stretched into fine, delicate threads by the wind. Pele's tears are the small, solidified, teardrop-shaped droplets often found at the end of these strands. And Limu o Pele, or Pele's seaweed, is a rare phenomenon that occurs when lava flows into the ocean and the resulting steam explosion blows the molten lava into thin, fragile, translucent sheets of glass that look like seaweed. And if you think black or red lava is the only kind, you'd be wrong. The El Doño Langai volcano in Tanzania is the only active volcano on Earth that erupts carbonatite lava. It's a bizarre, cool lava, only about 500 to 600 degrees Celsius, and it flows with the viscosity of motor oil. When it erupts, it's a fast-moving jet-black river, but as it cools and reacts with moisture in the air, it rapidly turns a ghostly white, making the volcano's peak look like it's perpetually covered in snow. But all of these events, as terrifying and spectacular as they are still fundamentally local or regional disasters. They can destroy cities, alter landscapes, and kill thousands. But there is another class of volcano entirely, a creature of such scale, such power, and such profound global consequence that it doesn't just threaten cities or countries. It threatens civilization itself. We have arrived at the supervolcano. A supervolcano is not defined by the size of its mountain. In fact, most of them don't look like mountains at all. They are defined by the sheer, mind-boggling volume of their eruption. A supereruption is an eruption that ejects more than 1,000 cubic kilometers of material. To put that in perspective, the 1980 eruption of Mount St. Helens ejected about 1 cubic kilometer. A supereruption is 1,000 times bigger. It is an 8 on the Volcanic Explosivity Index, VI, the highest level there is. And the most famous supervolcano on Earth, the one that looms largest in our collective imagination, is hiding in plain sight, disguised as one of America's most beautiful and beloved national parks, Yellowstone. There is no giant, cone-shaped mountain at Yellowstone. That's because the whole thing is the volcano. The massive 70-kilometer wide depression, or caldera, that makes up the center of the park is the collapsed crater from its last supereruption 640,000 years ago. The geysers like Old Faithful, the colorful hot springs like Grand Prismatic, the bubbling mud pots, these aren't just benign tourist attractions. They are the visible signs of a truly colossal magma chamber, a reservoir of molten and semi-molten rock the size of a city, simmering just a few kilometers beneath the ground. Yellowstone is not a dead volcano. It is a sleeping dragon. And it is breathing. The entire Yellowstone caldera floor is constantly rising and falling, sometimes by several centimeters a year, as magma and gas shift and move in the chamber below. So what would happen if it were to wake up? It would not be a sudden surprise. For years, or even decades, leading up to a potential eruption, the signs would be unmistakable and increasingly alarming. Swarms of earthquakes, thousands of them, would shake the region daily. The ground would swell upwards dramatically by meters, not centimeters, as the magma chamber inflates. The temperature and chemical composition of the geysers and hot springs would change drastically. Scientists at the Yellowstone Volcano Observatory are monitoring the park with a dense network of seismometers, GPS stations, and gas sensors. They are watching its every breath, its every heartbeat. But if it were to blow, the event would be apocalyptic. It would likely begin with a catastrophic explosion that would send a column of ash and gas 50 kilometers into the stratosphere. The sound would be one of the loudest in human history, heard thousands of kilometers away. The immediate area for hundreds of kilometers would be devastated. But the true terror would come from the collapse of the roof of the magma chamber. As the magma erupts, the ground above it would collapse, triggering pyroclastic flows on a scale that is difficult to comprehend. These glowing avalanches of ash would not just flow down valleys. They would surge over entire mountain ranges, burying hundreds of thousands of square kilometers, an area the size of several states, under meters or even tens of meters of incandescent ash. Anything in their path, cities, forests, rivers, would be instantly and completely obliterated. But the local effects, as catastrophic as they would be, are just the beginning. The next stage would be the ash fall. A thick, gritty, choking layer of volcanic ash would blanket the entire United States, and indeed much of the northern hemisphere. A few centimeters might not sound like much, but it would be a civilization-ending event. It would collapse most modern roofs. It would clog and destroy the engines of any car, truck, or airplane, grinding transportation to a halt. It would contaminate water supplies, making them undrinkable. It would short out the electrical grid, plunging the continent into darkness. And most critically, it would destroy agriculture on a continental scale, burying farmland under a layer of what is essentially powdered glass, and killing livestock that eat the ash-covered vegetation. And that leads to the final, most terrifying, and most global consequence: a volcanic winter. The eruption would inject hundreds of millions of tons of sulfur dioxide into the stratosphere. This gas would react with water vapor to form a fine mist of sulfuric acid droplets, a reflective haze that would encircle the globe and reflect a significant portion of incoming sunlight back into space. Global average temperatures would plummet by 5 to 10 degrees Celsius. In the northern hemisphere, it might not snow in July, but it might frost. Growing seasons would fail not just for 1 year, but for a decade or more. The result would be a global famine, the collapse of supply chains, and a potential breakdown of civilization as we know it. Does this sound like hyperbolic science fiction? It isn't. It has happened before. The last supereruption on Earth was Mount Toba in Indonesia, about 74,000 years ago. It was 10 times larger than Yellowstone's last blast, ejecting nearly 3,000 cubic kilometers of material. The volcanic winter it triggered was so severe that some geneticists believe it created a human population bottleneck, reducing our ancestors to just a few thousand individuals worldwide, pushing our species to the very brink of extinction. We are all, quite possibly, descendants of the survivors of a supervolcano. And Yellowstone isn't the only one. There are other slumbering giants, like the Long Valley caldera in California and Lake Taupo in New Zealand, which had its own supereruption just 26,500 years ago. These are the threats that hold the power of global catastrophe. It's a terrifying thought that the Earth itself, our home, holds the power to effectively end our world as we know it. But here's the final, crucial secret. Volcanoes are not just destroyers. They are also, fundamentally, creators. They are an essential part of what makes our planet a living, breathing, dynamic world. Volcanic outgassing over billions of years released the water vapor, carbon dioxide, and other gases that created our early atmosphere and our oceans. The incredibly fertile soils of places like Italy, Indonesia, and the Nile Delta are the direct result of nutrient-rich volcanic ash, which is why so many people, historically and today, live in the shadow of volcanoes. The Hawaiian Islands and countless other islands across the globe would simply not exist without volcanoes building them up from the seafloor. And the connection to our very existence might be even more profound. One of the leading theories for the origin of life on Earth is that it began not in a warm little pond, but in the dark, chemical-rich, energy-gradient environment of deep-sea hydrothermal vents, a form of underwater volcanic activity. The same elemental force that buried Pompeii may be the very force that sparked the first life on our planet. Volcanoes also play a critical role in Earth's long-term climate regulation, acting as part of the carbon cycle that has kept our planet habitable for billions of years. So we are left with a paradox. We live on a world that is both a nurturing mother and a terrifying monster. The volcanoes are a visceral, powerful reminder that the planet is not here for us. We are just temporary passengers on a dynamic, violent, and incredibly powerful geological machine. They are terrifying, but they are also a sign that our planet is alive, that it is not a dead, silent, geologically inert rock like Mars or the Moon. And perhaps, a dead planet would be an even more terrifying place to live. We have journeyed to the heart of the Earth's fury. We have seen its power to destroy and its power to create. We have seen that the greatest threats are often the ones we can't see, the sleeping giants hiding in plain sight. The story of our planet is the greatest, most terrifying, and most beautiful story ever told. And if you believe that, if you want to continue peeling back the layers of our incredible world to understand its secrets, then do us a favor and hit that subscribe button and turn on notifications. It tells us you want to be part of this journey. And if this story left you with a sense of awe for the raw power and beauty of our planet, share it with someone who needs that reminder. Thank you for joining our exploration of the Earth's fire. Stay curious and stay safe.